Okay, so we are going to start taking derivatives that will need you to possibly go back to the logarithms unit from advanced functions and review some of the rules / skills. So one of the things that we may or may not have gotten to, but you'll need to take care of it. I hope to have covered it in a lesson and attached it onto the Google site for this, and I think it's the first one in the bunch, is natural logarithms. So natural logarithms are ln. That is French for logarithms naturel or something like that. Rusty French. And that is the most common logarithm used in calculus. So I hope you remember that you can't just have log, or in this case ln, all by itself. Instead, you have to have something behind it. That thing is called, I believe it's called an operator. So you're taking the ln, or the natural logarithm of an operator. Another reminder is that ln is a special logarithm. It's base e, and then you have to take it of something. So when you take the derivative of ln, it's literally 1 over whatever that operator is, so repeat. And then you have to multiply it by the derivative of the operator. So we're going to do a couple of examples, and then we'll do a question for a purpose. This will lead into the next lesson, which is talking about the opposite of logarithms, which is the exponential function. That is this. Again, there is a ln and e lesson in the Google site for you to look at. So back to this. Just a little bit of moving around, and hopefully I will have enough space without making the page too long. All right, so the way it's written is fine. So I don't need to dig out black again and rewrite y like we did in those first couple of lessons of derivatives way back for me last week. So I'm going to take the derivative. So if I follow this rule, it's 1 over the derivative of what you are lning, and then multiplied by the derivative of this thing. So the derivative of that thing is 1. And 1 is 1 over 1. So our end result for y prime is 1 times 1 is 1 over x plus 3 times 1, which is x plus 3. The end. Now, of course it isn't always that easy. Let's take a look at this one. So again, I'm not going to worry about how it's written this way. It's good to go. So y prime equals 1 over what you are lning, no changes, no typos, multiplied by the derivative of this. So the derivative of this is more than a 1, so I must put it in a bracket. So it'll be 2x from that first term plus 3 plus 0. And again, that's over 1. So my end result for y prime is 1 times 2x plus 3, so 2x plus 3, over 1 times x squared plus 3x plus 1, which is x squared plus 3x plus 1. And of course, it's not always that easy. And the reason is because we've got all those rules that we have to worry about from the first unit, meaning you have to worry about the chain rule and the product rule and the quotient rule if they come up. So the next questions, I want to deal with them kind of at the same time. This question means, just in case you care, it means this. Now, I'm not going to use this. The reason is because this would require the extended product rule, and I'm not prepared to do it. So when I'm going to do the derivative, I'm going to work from the original. But I do want to distinguish how that's different from this one, which is this. So when the 3 is on the outside, that means it's the whole bracket written 3 times and multiplied, as opposed to when the 3 is written inside the bracket, and that is it only applies to the operator. And again, with this particular question, I am going to take care of it from the original. So now that you know the difference between the two, we can take the derivative. I'm going to use the other version. And this requires the chain rule, so I hope I've positioned this okay. So you drop the 3, keep writing, make it a 2. Then multiplied by, you've dealt with the 3, so this is back to the Russian dolls. Take the derivative of ln x, which is 1 over x, and then take the derivative of x, which is 1. So anything that isn't a fraction is over 1, and then I can make this look pretty. So 3 times ln x squared times 1 is 3 times ln x squared. And then 1 times x times 1 is x. Now, I do want you to realize that there is an alternate answer, and it looks very trig-like, and it's the abbreviation that requires no brackets. So really, the original question could have looked like this. And it would mean the exact same. This one has no alternate, so I am going to take the derivative of it, meaning blue. So there is no outside of this one, so I'm going to take the derivative of ln, 1 over what we're lning, multiplied by the derivative of this, which is 3x squared, and we have no more insides to do, so I can put that over 1, and then I can multiply across the top and across the bottom. And if you leave it like that, I can't give you full marks because there is some reducing to do. I can take an x out of each level. Sorry, an x squared out of each level. So, why is this a thing? Like, why does it work out that way? And the reason is because I do want you to know that the original question, if you remember your logarithm rules, there's a rule, there's a law of powers that lets you write it like that. That's got nothing to do with derivatives. Now, if we take the derivative, we leave the 3, take the derivative of ln x, take the derivative of x, and get exactly the same thing. So knowing your logarithm rules will help you. All right, next set of questions. Here we go. This one, super tricky. The derivative of ln 2 is 0. This is a constant. If you type ln 2 into your calculator, you will get a number. There are no x's. Now let's say you don't recognize that. That's why I left this room here. You can do 1 over what you're taking the ln of, and then take the derivative of what you're taking the ln of, which is 0, and 0 times anything is 0. So it'll still work out if you forget that ln 2 or ln of any number is a number. So here we get into the old rules, the basic rules of calculus. So this is a product rule question. And I'm going to do this textbook style, meaning I'm not going to break it down. So the derivative of the front times the back plus, for product rule, the derivative of the back, 1 over what you're lning, multiplied by the derivative of that, multiplied by the front. So remember, this is our breaking point, meaning we have to do math before and after that. There is absolutely no math to do at the beginning of this that will make it look any prettier. Plus, if it helps, over 1 over 1. 1 times 2 times 4, x cubed, over 2 times 1, x. Repeat the front, plus we can reduce this. So 8 divided by 2 is a nice nifty little 4, and then 1x out of each level is this. So I'm going to give you an OR. Hopefully you can see it without me drawing too much attention to it. I can common factor out of 4x squared from here and here. And you may have to do that in the future. Leaving behind, I'm going to use a square bracket because my round bracket is used here. 3 ln 2x plus I remove the whole 4x squared. We get that. So that is the OR answer. And yes, you need the brackets around this because the ln of 2x is not the same as the ln of 2x. Nobody can tell the difference without the brackets. All right, last question for no purpose. And you're sitting there thinking, oh crap, I've got the quotient rule here. And the honest truth is, no you don't. If you know the rules of logarithms. So I'm still going to dig out my black pen, not taking the derivative, and reminding you that if you have a division statement, you can take the derivative of each of them. Sorry, you can separate it into each having a ln with a minus sign. This is the law of subtraction from the logarithms unit, which are what lns are, or it's the law of subtraction, depending on how you look at it. Now, why couldn't we do that with the last question? Because the product didn't fall entirely behind ln. So you weren't taking the natural logarithm of a product. You are taking the natural logarithm of a quotient of a division statement here. So now that we have that, and no, this isn't a thing, there is no rule for plus. Now, what we can do is I can dig out my blue pen and start to take the derivative. So the derivative of this is 1 over what we're lning times by the derivative of it. 1 over what we're lning, totally bad math language, times that, over 1 over 1. So that's 2 over, oops, wrong color, 2 over 2x minus 1 over 1 plus x. My 2's will cancel out. And you get this. So this is a perfectly acceptable answer depending on what it is that you want to do with it. So I'm going to remind you how to get a common denominator in case that is necessary. So this is a bunch of OR. So I want to remind you, and I'm just going to rewrite it so I can scribble around it, of the 1, 2, 3 thing from advanced functions, which helps you get a common denominator. 1, multiply those two things together. Doesn't look like much, but there's your common denominator. 2, must go in that direction, so you must go up to the left. So that's 1 times x plus 1, which is x plus 1, minus 3, must go up to the right, and you must toss down that minus sign, which is causing all these problems to begin with. And this time I have to do x times 1, which doesn't need a bracket because I can do that pretty simply. And then my other y prime answer will be x minus x, which is 0, and then 1 over x times x plus 1. So there is your alternate answer if you need to do more math with it. Okay, so we are on to why we do this stuff. Yikes! Find an equation for the normal line. So this is, whoa. Let's try that again. Oh my gosh. I think it's because I'm leaning on my mouse pad. The equation for the normal line. So first things to notice, equation. Second thing, we'll have to find slope of the tangent and then do negative reciprocal. So as I said in unit number 1, chances are pretty good that if you take the derivative, you're on the right track. So we're going to take the derivative of this, which is unfortunately where we do actually have to do the quotient rule. So the derivative of the top, outside, inside, multiplied by the bottom, minus for quotient rule, derivative of the bottom, that'll be a 0. Woo, that's nice. 1 over ln x times 1, which is the derivative of x, times ln x squared, all over 1 plus ln x all squared. And no, you cannot knock those two things out. You can't do it because it's attached by minus. So you have a choice right now. You can either sub in the 1 right away, or you can clean it up. I'm choosing to clean it up just a little bit. So this stuff will become an x in the denominator, and the 1 plus ln x will remain in the numerator. So I've taken an x out of each of these. 1 remains on the bottom. Minus 1 times 1 times ln x squared is ln x squared over x. And no, you're not allowed to knock those out. This is without a ln. This is with it. And you can do more than just this, but because I have a number, I see it as very pointless. So I am now going to take x equals 1 and put it in for every single x. Now this is good, and I don't know if you can recognize why it's good. So let me jot this down for a second, then explain it. So this x is a 1, and 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 now let me remind you why this is a good thing. Now remember my calculator's backwards. 1. Hit the ln button. Oh my gosh, that's amazing. Anytime I see ln 1, it's 0. So that's 1 plus 0 over 1. That's 1 squared is 1, so that's 0 over 1. 1 plus 0 squared. So this is 1 over 1, which is 1, minus 0 over 1 squared. So we get the slope of the tangent is equal to 1, or 1 over 1. And the reason I do that is because if I remember back to the original question, I need the slope of the normal, so I can do the equation of the normal. So I need to flip this upside down, not that you can tell, and make it negative. And then I'm going to pretty it up. So that's the slope of the normal. So, things I need to keep clear. The slope we're going to use is -1. The x we're going to use is the one given in the question. And the y we're going to use is not this terrible thing. We're actually going to put 1 in there as well so that we can get a regular looking y. None of this letter crap. And I'm still excited because that's 0 over 1 plus 0, which is 0. So I have this and this and this to do my y equals mx plus b with. So y equals mx plus b. 0 equals negative 1 times 1 plus b. 0 equals negative 1 plus b. I need to keep b isolated, so I'm going to take the 1 across and add it, and then give you, therefore, the equation, my hand's cramping, of the normal being a line at x equals 1 is y equals m is negative 1 x plus b. Now a reminder that even though this doesn't have some messy fractions, you could have standard form, which requires you to put x first, y second, numbers last, or the alternative to standard form, not much difference, x's and y's on one side, x first, y second, and numbers on the other. So you have a multitude of different answers. So I know I haven't labeled them in the past. This one is called general form, y equals mx plus b. And these two are called standard form. Standard form typically is ax plus by plus c is equal to 0. Excuse me. All right, so that is it for ln x. I'll be back to go through more derivatives. Remember, they're never ending. But this is the stuff. So there is a sheet on the Google site, and that sheet is sheet A and number 1 to 5 to take care of the derivatives. The end. Hey, that's not so bad.